Question 4. Name the reagents that the student could use to identify that the sample was pent-1-ene. So you're looking for presence of a double bond, so you could use bromine or bromine water. Observation is that it goes from orange to colourless. Name the reagent used to identify the sample was pentanoic acid. So the easiest way of doing this is adding something like sodium carbonate that's going to form bubbles. I suppose you could add a universal indicator which would go orange, but sodium carbonate producing bubbles or effervescence, but bubbles is easier to write down than spell, so bubbles will get you the mark, is the best answer. Name the reagent sample was pentanal, so an aldehyde, so you're looking for Tollens reagent. Now at AS you'll get away with Tollens reagent. At A2 you need to put warm Tollens reagent, and the observation is a silver mirror. Alternatively, you could use failing solution that would give a brick red precipitate. So at AS Tollens reagent will get you the mark. Warm Tollens reagent is needed. The word warm, the condition is needed at A2, gives a silver mirror. As I say, failing solution given a brick red precipitate would also suffice. The student deduced that the spectrum was that of pentanal. So pentanal has got a carbon to oxygen bond in it at the end of a chain. Justify this deduction and suggest why the spectrum cannot be that of pentan-1-ol, pentanoic acid and pent-1-ene. So for 4 marks, so I think first of all you need to say what's in this that identifies the carbon to oxygen double bond, and what's not in this that should be present if it were pentan-1-ol, pentanoic acid and pent-1-ene, to show that it's not these 3. So pentanal has got a carbon to oxygen double bond, so you need to look up in your data table what absorption that's got. It's going to turn out to be this one here. And then you need to work out what an OH is in an alcohol, where that would appear. It's presumably not present. Pentanoic acid, so an OH in an acid, where that should be, and presumably that's not present. And a carbon to oxygen double bond in the ene won't be present either. So absorption at 1680 to 1750. By the way, you need to quote these numbers from the data book. If you don't quote the numbers from the data book and write them down, it's only a matter of copying after all. If you don't copy these numbers down, then you don't get the mark. So there is an absorption at 1680. There it is. It's absorbing due to the presence of a carbon to oxygen double bond in the pentanal, and there's no absorption at 1620 to 1680. There's nothing there. 1620, so we'll be about here. There's nothing here that be caused by a carbon to carbon double bond, so it's not pent-1-ene. No absorption 3230 to 3350, which would be the OH in an alcohol, so it's not pentan-1-ol. An OH in alcohol, by the way, gives a very, very broad absorption. It's not a sharp absorption like that, it's a very, very broad absorption, and it's not there at 3230 to 3350. It's just not here, that broad absorption for an alcohol, and there's no absorption at 2500 to 3000, which would show the presence of the acid, so it can't be pentanoic acid because there's nothing here in this region here, 2500 to 3000. They're not really significant absorptions. I think those are due to carbon to hydrogen or carbon to carbon bonds.